Okay, so this big long mess up here is just an indicator that we're doing, a polynomial function as so the powers are gonna be decreasing, so 6, 5, 4, 3, 2, and so on. And then these are just your coefficients, and then of course, frequently we have a constant at the back, so sometimes that kind of throws you off, it looks crazy, but it's stuff that you've already seen. Alright, so the shape of a polynomial function would be its smooth curves with no breaks or gaps, so basically no discontinuities, and are continuous for like all real numbers, which means your domain is going to be all real numbers. The degree is determined by the highest exponent power, which in this, like in the example up there, would be whatever your highest n value is. And y'all saw this in algebra too. So if we look at the different degrees in classification, this is a constant, so it's a degree 0. Is a constant function, just a horizontal line. This has a power, x has a power of 1, so it is linear. The next one is x squared, so it's a degree 2, that is quadratic. The next one is x to the third, so degree 3, cubic. And then quartic. And then quintic. All of which we kind of talked about in algebra 2. Alright, so then they're talking about the end behavior of each of these things down here. And your even powers, we really, I think, looked at this pretty much almost exactly like this yesterday or the day before. So as x approaches infinity, f of x is approaching infinity. And I'm just going to write this part right here like negative infinity and infinity rather than writing that all the way out every single time just for the sake of saving some time. Then if we had a negative out front of x squared, you'd have as x approaches infinity, f of x would approach negative infinity, and the same on the other side of that. And so all your even powers are going to do the same thing. And really, in all actuality, they kind of, even the reason we go through this is a lot of times they expect you to be able to answer that question without actually seeing the graph. So you're just kind of knowing in your mind, if it's an x to the 4th, x to the 6th, this is its overall end behavior. It's going to be the same regardless of what happens in the middle. And then your cubics, as x approaches infinity, f of x approaches infinity, and as it goes to negative infinity, it goes to negative infinity on the other side. And then this one, when we put the negative out front, it's just going to be the opposite. X approaches negative infinity, and then negative infinity, and positive. So, again, nothing really new, just a reminder. We okay there? Any questions at all? You all good? All good. Okay. Alright, let me flip over here. Okay, so just kind of a quick little thing that might help you if you're leading, and you do have to be written in standard form with your highest power first, you'll know that. So if you have even and it's positive, then it's always going to go like this. If it's even and it's negative, it's always going to do this. If it's odd positive, it's going to do this. And if it's odd negative, it's going to do that. Like, doesn't matter what the power is. So because of that, we're not going to work through every single one of these. I just want to make sure that y'all are comfortable. So let's go look at, let's say number 4. How would we write the end behavior before? The end behavior for number 4. So as we approach infinity, what is f of x going to do? So it's degree what? 7, so it's odd, positive or negative? Positive, so it's gonna do whatever this is, which means f of x is going to where on the right side? Positive infinity, and as x approaches negative infinity, f of x is gonna go to negative infinity. Y'all okay with that, how that works? Like, does that help you to just kind of have that as your little like guide? Because it does not matter, I could have x to the 25, it wouldn't matter if it's positive, if it's gonna do this, if it's negative, it's gonna flip and do the opposite. And as long as you know, like you know this, y'all know what those end behaviors are, so you don't really ever have to see the graph to be able to give the end behavior. Alright, if we come down here and we look at number 7 down here, they're wanting you to describe both the power and the coefficient of the leading term. So basically, is it odd or is it even? And is it positive or is it negative? That's really what they're asking us here. So if we look at this graph, is it odd or is it even? It's going to be odd. If we're going in opposite directions, it's going to have an odd power. Now, it's coming down this direction. So was my leading coefficient negative or was my leading coefficient positive? It had to be negative. And we can kind of look at the powers too. We know that, so if we look at the direction change, and I kind of count these, I count this as 1, 2, 3, 4, 5. It's x to the 5th or higher. That could be 7 or 9 or whatever, because sometimes things can, like zeros can repeat and things like that, but it's at least x to the 5th, could be more, but it must be odd negative. Are we good there? Alright, so this one, even or odd? Even, positive, or negative? Positive. And it could be up to, looks like 4. Could be more, it could be 4 or more. Can't be less though. Everybody okay with that? Okay, so then they want us to look at like these direction switches. Again, this is something we did do before. This is just a reminder. If my arrows are going in opposite directions, then this has, like this right here has to be a relative maximum, which is what goes here. This has to be a relative maximum, and this one right here would have to be a relative minimum, as opposed to an absolute, because there's an arrow that goes past it. Does that make sense? So this is a relative max. So it's a high point, but it's not the highest. And this is a relative min. A minimum for the area that it's in, but it's not the minimum for the whole graph. If we have a maximum or a minimum, those are called extrema. Also things we've already talked about. And then of course our turning points are where we determine the change in increasing and decreasing behavior. This down here kind of goes through how to find those values in your calculator. We've already done that, so we're not going to really go through that. But the directions are there for you if you need them. So if we graphed this right here in our calculator, I'm just going to tell you what they are, and then if you want to check them, you can. This would be a -4 and 47. I know that this graph is going to do something like this. I don't know exactly what it looks like, but I know overall it's going to do something like that. So it's going to have a relative maximum at -4 and 47, and its minimum ends up being at 0.67 and -3.8. That's what I got from my calculator. So if that's the case, then I'm basically increasing to this x value right here, which is at -4, and then I decrease to this x value right here, which is 0.67. You okay with how that would work out, how that works out? So if we wrote because I really care about the y value, if I write my increasing interval, then that's going to be from negative infinity until I get to -4 increases, and then it's going to decrease from, from -4 until I get to 0.67, and then it's going to turn and increase again from 0.67 to infinity. Y'all okay with That one? Okay. So, I said, things y'all seen before, just kind of a reminder. Alright, any questions on that at all, or y'all are good? Okay, so we're gonna do a couple on a graph, and then I'm gonna let y'all just work through, cause y'all should be pretty comfortable with this. So, which one do y'all wanna look at? Cause it doesn't matter to me. I'm gonna say probably not just a regular quadratic, cause that's a little bit basic. So let's pick two, and we can look at them. In fact, I know we're gonna look at six, because it does a little bit of a weird thing. But what about on the front? Is there one y'all wanna just pick and do? Y'all have a preference? I know, like I said, I know we're gonna do six, some of that. Alright, let's do this. Boys, will y'all graph number 2 in your calculators? And girls, will y'all graph number 6 in your calculators, so we can get that stuff. Alright, so we're gonna do 6 for sure. And then we're gonna look at 2. And I'm gonna go ahead and fill some of this out while y'all are graphing, and y'all can kind of look up and get it in a minute. So, because the classification, it's cubic, I'm just gonna kind of fill some of these out. The domain we already know, and the range we already know. And the end behavior. Once y'all have it graphed, we'll start getting this stuff on. Okay. I'll have some points in your calculators. Let's go to the table and try to get some halfway decent points. What you got on there?
You got -2, -1.
-2, -1, okay.
And -1, -7.
-1, -7, okay.
0, -1.
1, okay.
And 1, 5.
Okay.
And 2, -1.
Okay, alright, so we kinda know overall what the shape is doing. Alright, there's gonna be a minimum over here. Preston, will you get that minimum? And Antonio, will you get this maximum over here? Cause I don't know that I don't think those points are actually at the minimum max. They might be, but I'm not sure.
-1.5.
Okay.
And -7.1.
Okay, so it's just a little bit below this, alright, so pretty much up there, okay. Alright, Antonio, Preston, let me write that again. -1.5, and the Y value is what?
Or 1.15. 31.5. Or 2. Oh my god.
-7 point,
1.15.
okay, so we'll call it 7.2, okay. So that was your relative minimum, alright. Antonio, you write down the maximum. What'd you get there? 1.1 and what? 5.1? Okay. Did you round those already? Okay. Alright, so roughly 1.1 and 5.1, so it's really just right above where this point is. Alright, so. Something like that, mine's really wobbly, but. Get the idea. Okay, so then, I'm gonna write those in over here, sorry, I forgot that over here too. Maybe 1.5, and 7.2, and y'all's maybe slightly, your decimal point, sometimes they're slightly off, so, but as long as they're pretty close, we should be fine. Alright, so what do we do first? Increase, decrease, what? Decrease, so we're gonna decrease, I'm gonna write it first, so I'll go negative infinity until I get to -1.5, and then I increase from -1.5 until I get to 1.1, and then I'm gonna pick back up from 1.1 to infinity. Y'all okay on that? I said, none of this is really new stuff to you, I just wanna make sure we're okay. And I apologize if my graph is terribly wrong there. Okay, so this one here does kind of a crazy looking thing. I mean, I know overall it's doing this, but I know there's some stuff in the center. So it must have an absolute max somewhere. Catherine, do you have points off the table yet?